Hi all, this is question number 26 from GATE 2021. The question says that we are given this ring R, A plus, this is basically Z square root of minus 17, this ring. And we want to know whether this element 2 plus square root of minus 17 inside this ring is an irreducible element or not, or whether it is a prime element or not. Okay, so let's see this. So 2 plus square root of 17. So let's check the statement P first. So let's say that this is not irreducible. So this suppose 2 plus square root of 17 is reducible. Then 2 plus square root of minus 17 is equal to A plus B square root of 17 times C plus D square root of minus 17. Okay. Let's say that this is Z1 and this is Z2. Okay, so we take norm both sides. So this will be norm of Z1 times norm of Z2. Okay, norm of and norm we are defining to be norm. We are let's say that norm is denoted by n. Norm we are defining to be norm of Z1, for example, is A square plus 17B square. So this is norm. So norm will be equal to 21 of this element, and this will be equal to norm of Z1 times norm of Z2. Now norm are integers, and we know that so we were assuming that this was reducible, so these two are basically non-units. So and we know that norm of Z is equal to 1 if and only if Z is a unit, right? We know this fact. So what is the possibilities that the norm of, so this has like factorization 3 into 7. This is the only factorization. Another factorization is 1 into 21, but norm of Z1, norm of Z1 or Z2 cannot be 1 as they are non-units. We are assuming this element to be reducible. Okay, so the only possibility is that norm of Z1 is equal to 3 and norm of Z2 is equal to 7. But are there any solutions of this equation? So norm of Z1 was equal to A square plus 17B square. So this equation does not have solutions in Z integers cross integers. A and B both belonging to integers. So this factorization cannot exist, and this factorization cannot exist. So 2 plus square root of minus 17 is irreducible. Okay. And what about the other statement? So yeah. So the other statement, we want to check whether this element is a prime element. So 2 plus square root of minus 17 times 2 minus square root of minus 17 is what? This is 4 plus 17, which is 21. And 21 can be written as 3 times 7. Okay. So for to check that an element is prime, if P is prime, so P is prime. What is the definition of prime? That P is prime. If P divides AB, then P either divides A or P divides B. So we have to check whether 2 plus square root of minus 17. So 2 plus square root of minus 17 divides um, 3 times 7. So it either divides 3 or 2 plus square root of minus 17 divides 7. But is it true that this happens? So norm of this thing is 21 and norm of this thing is 9. So if this divides this, then norm of this divides norm of this, but this isn't true. So this cannot happen, that 2 plus square root of minus 17 divides 3. What about this? So norm of this is 21 and norm of 7 is 49. So again 21 doesn't divide 49, so 2 plus square root of minus 17 cannot divide 7. Okay, so we have found violation of this thing, right? So P is not a prime. Sorry, 2 plus square root of 17 is not prime. Now let me write on the next page. So statement P is true, and this is true, and this is false, and B option is correct.